Hey, have you ever looked up at the night sky? Have you ever just, felt that sense of wonder wash over you? The stars, they twinkle back at us from across these impossible distances. They're like silent witnesses to the vastness of time and space. We're small fleeting beings on this tiny blue dot, right? But still, we have the capacity to ask the biggest questions. We can look beyond our own lives, beyond our own world. We can ask about the universe itself. What's its story? Where did it all begin? And maybe, just maybe, the most profound question of all, how will it all end? Could the end actually be a new beginning? Our universe, well, it had a beginning. We call it the Big Bang. About 13.8 billion years ago, everything we see around us was compressed into this unimaginably hot, dense point. And then it began to expand. From that initial moment of creation, the universe has been growing, cooling, and evolving. Gravity began to pull these simple elements together. In the hearts of these collapsing clouds, the first stars ignited. They were like cosmic furnaces, forging heavier elements in their cores. They lived these brilliant lives and then died in spectacular explosions. Those explosions scattered the new elements across space, seeding the next generation of stars and planets. We are made of that stardust. The iron in our blood, the calcium in our bones, the oxygen we breathe, all of it was created in the hearts of long-dead stars. The idea of a final end can feel pretty bleak. A universe that just fades into eternal darkness. Yeah, that's a lonely thought. But what if that's not the only option? What if the end is actually just the start of something new? That's really the core of the idea of cosmic rebirth. Some physicists propose that as the universe collapses back in on itself, it could bounce. This is what's known as the Big Bounce. Other theories, like cyclic models based on string theory, suggest that our universe could collide with another brane. Such a collision would trigger a new Big Bang. This cycle could repeat endlessly, a cosmic heartbeat of expansion and contraction, of death and rebirth. So to really understand how the universe might end, we have to first journey back to its beginning. We need to travel in our minds to a time before time itself. At that instant, everything that makes up our universe was concentrated into a point of infinite density and heat. This point, known as a singularity, is honestly beyond our current ability to fully describe. In the first fraction of a second, the universe expanded exponentially, growing from a subatomic size to something unimaginably vast in an instant. This primordial fireball was incredibly hot, trillions upon trillions of degrees. It was a chaotic soup of fundamental particles, constantly being created and annihilated. We see the afterglow of the Big Bang in the cosmic microwave background radiation. This is the oldest light in the universe, a snapshot from when it was just 380,000 years old. For hundreds of thousands of years, it remained a hot, dense plasma. The universe was opaque, like a thick cloud. There were no stars, no galaxies, and no planets. After about 380,000 years of cooling, the protons and electrons combined. They formed the first stable, neutral atoms, and the cosmic dawn began. The first stars blazed to life, ending the cosmic dark ages. Their brilliant light pierced the darkness, illuminating the universe for the first time since the initial flash of creation. When they died, they did so in spectacular fashion, exploding as supernovae. They scattered the heavier elements across space, seeding them with the raw materials for new kinds of creation. They were pulled together to form the very first galaxies. These were small, irregular galaxies at first, but they grew over billions of years through mergers and collisions. The story of the early universe is not just a story about distant stars and galaxies. It's also our own story. Every atom in our bodies, except for the primordial hydrogen, was created inside a star. Our own solar system formed from one such enriched cloud of gas and dust about 4.6 billion years ago. From this disk, the planets, including our Earth, were born. So when we look up at the night sky, we're not just looking at a collection of distant, unrelated objects. We're looking at our own cosmic family tree. We are the universe's way of becoming aware of itself. We are the product of 13.8 billion years of cosmic history, a living testament to the creative power of the universe. So, the universe began with a brilliant flash of light, and it's been expanding ever since. For billions of years, This expansion has been a sort of battle between two opposing forces. But then, in the late 1990s, astronomers made a pretty startling discovery. The expansion of the universe isn't slowing down, it's speeding up. If dark energy keeps dominating, the universe will expand forever, and at an ever-increasing rate. This leads to a scenario known as the heat death or the big freeze. Galaxies will just keep rushing away from each other, and the space between them will grow so vast that they'll eventually disappear from each other's view. The last generation of stars will flicker and die one by one. The era of starlight will come to an end, and the cosmos will slowly fade into an eternal cold darkness. Imagine for a moment a universe without starlight. After the last star has extinguished its light, the cosmos enters a profoundly different era. It'll be a universe of remnants. This universe is governed by the second law of thermodynamics. The universe will become more and more disorganized and uniform. All activity will have ceased. Even the black holes won't last forever. They'll evaporate in a final faint flash of light, leaving behind only a bath of low-energy particles. After the last black hole has evaporated, the universe will be almost perfectly empty. It'll be a state of perfect, eternal equilibrium. But it'll be a dead equilibrium. The Big Freeze is a bleak but scientifically plausible vision of our cosmos's final destiny. It's a universe that began in a blaze of glory and ends in a silent, unending whimper. But hey, what if dark energy isn't constant? What if it weakens over time or maybe even reverses its push? If dark energy were to fade away, gravity could once again become the dominant force. The expansion of the universe would slow down, grind to a halt, and then reverse. This would lead to a very different and far more dramatic end for the universe. Billions of years in the future, galaxies would start to collide and merge. The sky would actually start to fill with light again, as entire galaxies merge into one another. As the contraction continues, the universe would get hotter and denser. The background temperature of the universe would rise, eventually becoming hot enough to vaporize stars themselves. The final moments would be cataclysmic. All the matter and energy in the universe would rush together towards a single point. The universe would end in a final singularity. The fate of our universe appears to be sealed by forces we cannot see. The cosmic scales are tipped by two invisible giants, dark matter and dark energy. Dark matter makes up about 27% of the universe. Dark energy makes up about 68%. The ordinary matter that we are made of accounts for less than 5%. Our understanding of dark energy is still in its infancy. If its strength changes over time, the future could be very different. We find ourselves in a state of profound cosmic uncertainty. Unlocking the secrets of dark matter and dark energy is one of the greatest challenges in modern science. The possibility remains that our understanding is incomplete. The answer is hidden in the nature of the dark side of the cosmos. A different destiny awaits our universe, one that we have not yet even imagined. The Big Crunch paints a picture of a fiery, definitive end. But what if it is not? Some physicists look at this final singularity and see not an end, but a gateway. They ask a bold question: what happens if the universe, upon collapsing, rebounds? This idea gives birth to the Big Bounce theory. Imagine the universe as a giant cosmic lung. The Big Bang is the moment of inhalation, but eventually gravity takes over. The lung begins to exhale, and the universe starts to contract. Instead of collapsing into an unbreakable singularity, the fundamental forces of nature resist the final collapse. The universe, in essence, bounces back. This would be a new Big Bang. A new universe would emerge from the ashes of the old one, resetting the cosmic clock with its own 13.8 billion years of evolution ahead. The concept of a big bounce transforms our view of cosmic history. It suggests a cosmos that beats like a heart, expanding and contracting, living and dying, and being reborn again and again. In this model, the universe could have existed forever. There would be no ultimate beginning, no singular moment of creation from nothing. Each cycle might be slightly different. Previous universes could have been very different from our own. Our universe is just the current iteration. Entropy might be reset at each bounce. The incredible heat and density could wipe the cosmic slate clean, creating a new, low-entropy state ready for a fresh start. Scientists are looking for subtle clues. Some believe that faint signatures of a previous cosmic cycle might be imprinted on the cosmic microwave background. Another fascinating idea comes from string theory. String theory proposes that the fundamental constituents of reality are tiny, vibrating strings of energy. It postulates the existence of extra dimensions of space. In this higher dimensional reality, our universe could exist as a three-dimensional membrane, or brain. There could be other brains, other parallel universes, floating nearby. The model proposes that our Big Bang was the result of a collision between our brain and another. This collision would have been an event of unimaginable energy. The kinetic energy would have been converted into matter and radiation, creating the conditions for a Big Bang. In this cyclic version, the brains do not just collide once, they collide again, triggering another Big Bang and starting the cycle all over. Whether through a bounce or a collision of brains, these theories share a common theme. They propose that the universe has an innate ability to remake itself. The laws of physics themselves seem to allow for a universe that is not a one-time performance, but an eternal play with countless acts. These models challenge our perception of time. If the universe is cyclic, then time itself may not be a straight line with a beginning and an end. In a cyclic universe, the fundamental constants might be reset with each new cycle. We would naturally find ourselves in a universe suitable for our existence. They show us that science can imagine futures that are not bleak or final, but filled with the possibility of endless creation. The scientific theories of a cyclic universe are products of 21st century physics. Yet the core idea is not new. Long before we had telescopes, our ancestors saw cycles everywhere. The most powerful cycle was that of the seasons. The death of winter always gave way to the new life of spring. This pattern of decay and renewal was a fundamental truth of existence. This intuition gave rise to powerful myths and philosophies across the globe. These ancient ideas were humanity's first attempt to grapple with the grand questions of origin and destiny. In ancient India, Hindu cosmology developed elaborate systems of cosmic cycles. The universe undergoes endless cycles of creation and destruction, each lasting for billions of years. When we hear physicists today talk about a bouncing universe, we are hearing a modern echo of this ancient idea. The language has changed from myth to mathematics. Across civilizations, the idea of a cyclic universe took many forms, embedded deep within culture and religion. These diverse cultural expressions all point to a shared human intuition. The ancient Greeks explored similar ideas. The Stoic philosophers believed in ekpyrosis. The universe periodically perishes in a great fire, after which it is reconstituted in rebirth. The Aztec and Maya civilizations had incredibly sophisticated calendars based on a cyclical view of time. Their myths spoke of a series of worlds, each destroyed by cataclysm. Time was not a river flowing to a final sea, but a turning wheel of ages. The universe was not a machine that would run down. It was a living, breathing entity constantly renewing itself. This shows that the idea of cosmic rebirth is not just a mathematical possibility. It has resonated with the human spirit for thousands of years, offering hope in the face of cosmic immensity. The convergence of modern scientific theories and ancient philosophical traditions on the idea of a cyclic universe is truly remarkable. This shared vision offers us a cosmic philosophy. A cyclic universe changes our perspective on endings. In a cyclic model, an end is always a transformation. Destruction is not just destruction, it is the act of clearing the ground for new creation. If our universe is just one in an endless series, it connects us to something eternal. Our brief lives become part of a story that has no beginning and no end. This cosmic philosophy encourages humility. The idea that countless universes may have existed before ours puts our own cosmic moment in perspective. It's a philosophy that replaces cosmic anxiety with a sense of awe and participation in a grand, unending dance. The Big Bounce is a scientific theory, and the cosmic cycles of mythology are stories. Science relies on evidence, prediction, and falsifiable hypotheses. Myth relies on narrative, symbol, and meaning. Yet it is fascinating to see them arrive at a similar horizon. They both stand at the edge of human understanding, looking at the same ultimate questions. The quest for knowledge is not a linear progression where science simply replaces myth. Instead, our understanding evolves. The ancient myths can be seen as the first draft of our cosmic story. Science does not necessarily destroy the magic of the old stories. In a way, it rediscovers it, finding evidence for wonders that our ancestors could only dream of. Ultimately, both science and myth are expressions of our capacity for wonder. They speak to a deep hope for continuity, suggesting a universe that is not fleeting but eternal. So, why do these grand cosmic theories matter to us? We live our lives on a tiny planet, and the fate of the universe can seem distant and abstract. But these ideas about cosmic rebirth touch something deep within the human spirit. The thought of a universe that ends in a cold, silent void can feel pretty desolate. The idea of a cyclic universe offers a powerful alternative. It suggests that the cosmos has an innate resilience. This is a profoundly hopeful vision. It tells us that the universe has an innate resilience, an ability to begin anew. It's a cosmos that doesn't give up. It tries again and again, forever. This vision has the power to inspire us. The idea of a universe that constantly remakes itself is a powerful metaphor for resilience. It reminds us that endings are often opportunities for new beginnings. This cosmic hope isn't based on wishful thinking. It's grounded in the possibilities that science itself reveals. The universe might not care about us personally, but its fundamental nature might just be one of endless, hopeful creation. The theories of cosmic rebirth reshape how we see our place in the universe. In a single, finite cosmos, humanity can seem like a fleeting accident. A cyclic universe offers a very different picture. We are descendants of a universe that has lived and died many times before, and we are the ancestors of universes yet to be born. This replaces cosmic loneliness with a profound sense of belonging. Perhaps consciousness is a recurring feature of the cosmos. Our brief existence is part of a timeless tradition of life and awareness. We are the current guardians of that flame of consciousness. This gives our lives a sense of purpose and responsibility. We are participants in a magnificent, ongoing cosmic drama, not just passive spectators of its final act. We are part of a grand, unbroken chain of being, stretching across eternity. This knowledge can inspire us to cherish our moment in the cosmic light and feel a deep connection to the universe that made us. Ultimately, the human quest to understand the universe is a search for meaning. We look to the stars not just to map their positions, but to find our own. The idea of cosmic rebirth offers a compelling answer. It suggests that meaning is not found in permanence, but in participation. The significance of our universe is that it's part of an eternal cycle of creation. In this view, nothing is ever truly lost. The matter and energy that make up our world will be recycled and reformed into the next universe. The legacy of our cosmos is the seed of the next creation. If we see the universe as a place of endless renewal, it can encourage us to act with a longer-term vision. Our quest for knowledge, our creation of art, our acts of compassion can all be seen as our contribution to this cosmic cycle. The search for what happens after the universe ends leads us back to ourselves. In this grand and inspiring vision, our search for meaning finds a hopeful echo in the very heartbeat of the cosmos. We began our journey with a simple question, whispered to the night sky: how will it all end? This question has taken us on an extraordinary voyage through cosmic history. From the frontiers of physics, new and astonishing ideas have emerged. Theories like the Big Bounce and the ekpyrotic model suggest that the end of our universe could trigger the beginning of another. These ideas, born from complex mathematics, echo the ancient myths and philosophies of our ancestors. They connect our modern scientific quest with a timeless human search for pattern and continuity. This vision of cosmic rebirth changes everything. We are not cosmic accidents, adrift in a universe destined for oblivion. We are the children of a universe that may have lived and died countless times before. This perspective imbues our fleeting lives with profound and timeless significance. It connects us to the eternal heartbeat of reality. This journey is not just about understanding the universe, it's about understanding ourselves. So what does cosmic rebirth teach us about our place in the universe? It teaches us that we are part of a story far more magnificent than we ever dared to imagine. We are not separate from the cosmos, looking in from the outside. We are an expression of it. The human capacity for wonder is the universe's way of becoming aware of its own incredible journey. Our universe, with all its billions of galaxies, might be just one chapter in an infinite library of cosmic stories. We are part of a grand, unbroken chain of being, stretching across eternity. The search for answers will continue, Scientists will build new telescopes and particle accelerators, pushing the boundaries of our knowledge ever further. But the quest itself is what matters. Ultimately, the idea of cosmic rebirth leaves us on an endless horizon of possibility. It tells us that the universe is a place not of final answers, but of eternal questions. It is a place of perpetual novelty and endless creativity. When we look up at the stars now, we can see them as reminders of this grand cyclical story. We are living in a universe that might just be immortal, a universe that never truly says goodbye but always in the end says hello again, and that is perhaps the most wonderful thought of all.